How are you, my friends? This is Calculus 1 solved questions from lecture 12B. The questions are using hyperbolic functions. Question number 1, the function hyperbolic cosecant can be written as one of these A, B, C, D, and E. So just look carefully here and see we have something exponential divided by 2. So we have to write hyperbolic cosecant in one of these forms. Now, hyperbolic cosecant is the reciprocal of hyperbolic sine. So hyperbolic cosecant will be 1 over hyperbolic sine of x, which is 2 over e to the power x minus e to the power minus x. Let's multiply up and down by e to the power x. Now in the numerator, we have e to the power 2x. Down here in the denominator, e to the power x times e to the power x minus e to the power minus x times e to the power x. This will be in the power 0, which is 1. So we have 2 e to the power x divided by e to the power 2x. Here we add the powers because we have the same base, minus 1. So the answer is D. You can see that the answer is D. Question number 2, we need to find the value of this expression. 1 plus hyperbolic cotan of half divided by 1 minus hyperbolic cotan of half also. So the answer can be either E or minus E, minus 1 over E, 1 over E, 2 over E. Let's see. Now we can use this formula for hyperbolic cotan, e to the power x plus e to the power minus x divided by e to the power x minus e to the power minus x. Just apply directly, replace half in the x place here, e to the power half plus e to the power minus half divided by this minus this. And here we have plus in the numerator and here we have minus in the denominator. So let's combine now the fraction here. So this is like 1 plus x over y. So the LCD will be e to the power half minus e to the power minus half. You multiply that plus all this expression in the numerator, e to the power half plus e to the power minus half. Same thing we will do down. We will combine these two fractions with the minus before the bracket. Now we can cancel all this and all this. The denominators can be canceled. So we have e to the power half minus this plus e to the power half plus e to the power minus half. This is the same expression. We can cancel it. So we are left with same quantity here, e to the power half, e to the power half, 2 e to the power half. And here we can cancel e to the power half minus e to the power half. And this will be minus 2 e to the power minus half. Now we have the same base here, e and e, so we can subtract the powers. Half minus half, which is 1. And there is 2 and 2 canceled, and there is a minus outside. So the final answer is minus e, and this is choice B. Now question number 3 says, given the function y equals 1 plus hyperbolic tan of x divided by 1 minus hyperbolic tan of x. And we need to find the value of y prime evaluated at ln of 2. So first, we find the derivative of this function. And when we simplify it, we replace x by ln of 2. Please, you can try it. This is a very nice question. Now, let's start. Remember the quotient rule for the derivative. U over V all prime will be U prime V minus V prime U all divided by V squared. So we start here. The derivative of 1 plus hyperbolic tan of x times the denominator minus the derivative of the denominator times the numerator all divided by this squared. Now we know the derivative of hyperbolic tan of x will be hyperbolic secant squared of x. And the derivative of 1 is 0. So do we have here hyperbolic secant squared of x times this bracket minus, we have a minus here inside the bracket from the derivative minus hyperbolic secant squared of x times the last one divided by 1 minus hyperbolic tan of x all squared. Now, when you multiply all these, the hyperbolic secant squared and the hyperbolic tan, when you multiply, you will be cancelled with the same term. So what's left is 2 hyperbolic secant squared of x. Now we know the formula here, the identity, 1 minus hyperbolic tan squared of x is equal hyperbolic secant squared of x. We can replace that here. Then we factor by difference of 2 squares, 1 minus hyperbolic tan of x, 1 plus hyperbolic tan of x. Then we can cancel one of these, same bracket here. So the derivative now, y prime of x of this given function will be 2 times 1 plus hyperbolic tan of x divided by 1 minus hyperbolic tan of x. So the only thing we have to do now is replace x by ln of 2. Continue on the next slide. So this is the derivative here. And this is the hyperbolic tan e to the power x minus e to the power minus x divided by e to the power x plus e to the power minus x. Just let x is equal to ln of 2 from the given. So I replace now here every x by ln of 2. And then I start simplifying. It's a little lengthy here, but not difficult. E to the power ln of 2 is 2. And here is half because we take this minus on the power. So minus half, 2 plus half. And in the denominator, we have the same quantity here. Then we add the fractions. Here we divide 2 fractions. We multiply the first by the reciprocal of the second. And you simplify easy numbers here until you get 16 over 5 times 5 over 2. So y prime evaluated at ln of 2 is equal to 8 is the answer. Now, question number 4, find the limit of x minus 1 times hyperbolic cotan of ln of x as x goes to 1. Now, let's apply the definition of hyperbolic cotan of x written here on the right side, and then we evaluate that at ln of x. So we replace every x there by ln of x. So we'll get x plus 1 over x divided by x minus 1 over x. By finding LCD here, combine the terms, we get x squared plus 1 over x squared minus 1. So now I can rewrite the given function as x minus 1 times x squared plus 1 divided by x squared minus 1. I can factor in the denominator difference between 2 squares, x minus 1, x plus 1. Then I will cancel x minus 1. Now to find the limit of this function, we substitute x by 1. So 1 squared plus 1 divided by 1 plus 1. 2 over 2, the answer is, so the limit will be 1. Question number 5. The graph of this function, hyperbolic cosine of ln of x plus 4x, has a horizontal tangent at what x? 2 or 8? 1 over 4, 1 over 2, 1 over 3. So let's find the value of x. So first we have to find the derivative. We use the chain rule here. D over dx of hyperbolic cosine of u will be hyperbolic sine of u times u prime. So the derivative here will be hyperbolic sine of ln of x times the derivative of ln of x, which is u, plus 4, which is the derivative of 4x. Now I can replace ln of x in the definition of hyperbolic sine. It will be e to the power ln of x minus e to the power minus ln of x divided by 2 times the derivative of ln of x will be 1 over x plus 4. Horizontal tangent means the derivative of the function is equal to 0. So we put y prime is equal to 0. We take all this expression is equal to 0. This will be x from e to the power ln of x. That will be x minus 1 over x divided by 2 times 1 over x plus 4. Now this one we can combine here the fractions with LCD, x squared minus 1 divided by x, and there is 2, so it will be 2x there times 1 over x. Now x squared minus 1 times 1 will be x squared minus 1. 2x times x will be 2x squared. Take 4 on the other side, becomes minus 4. Cross multiply, you get minus 8x squared. Now move all the x on one side, you get 9x squared is equal to 1. So x will be plus or minus 1/3. Now why the minus is rejected? Because we cannot have logarithmic function with negative argument. So x is equal 1/3 is the correct answer, which is choice E for question number 5. Question number 6, let's find the expression of 1 minus hyperbolic cotan squared of x. Is that equal to minus hyperbolic cosecant squared, or hyperbolic secant squared, or minus hyperbolic secant squared, or hyperbolic cosecant squared, or hyperbolic tan squared of x? Let's see that. Now we know hyperbolic cotan of x will be e to the power x plus e to the power minus x divided by e to the power x minus e to the power minus x. So let's see, 1 minus all this expression definition here is squared. So we combine the fractions here. 1, see the LCD here is e to the power x minus e to the power minus x squared. It will be this one here. You see this one here? It will be all squared minus this one squared divided by this one squared. Now we can factor here, or we can expand by using the formula. A minus b squared, you know the formula a squared minus 2ab plus b squared. This one also a plus b squared, it will be a squared plus 2ab plus b squared. You can do that. But what I did here, I factored the numerator. See, this is like capital A squared minus capital B squared. So I put a minus b, a plus b. Just another way. So when you simplify that, you will get minus 2 e to the power minus x in the first bracket here, second bracket 2 e to the power x, leave this one here. Now when you multiply, you get minus 4 e to the power 0. You see, e to the power minus x, e to the power x, when you add, you get e to the power 0, which is 1. So minus 4 is there, divided by all this squared. Minus, see, leave this minus here. 4, make it 2 squared, 2 over this. See, there's another squared here, so it will be 2 over all this e to the power x minus e to the power minus x squared, which is minus 1 over hyperbolic sine squared. So the answer will be minus hyperbolic cosecant squared of x, which is choice, you can see here, choice A. Question number 7, find the value of the given expression. The limit as x goes to infinity of hyperbolic tan of x minus the limit as x goes to minus infinity of hyperbolic tan of x also. Now we know hyperbolic tan of x is e to the power x minus e to the power minus x divided by e to the power x plus e to the power minus x. Let me tell you this secret here. I will write the same function in 2 different ways. When I have the limit as x goes to infinity, see the first one here, I need something in the power e to the power minus, because when I replace x by infinity here, it will be 1 over infinity, which is 0. So easier to find the answer. And when I have the limit as x goes to minus infinity, I will try to leave the expression here as e to the power x positive in the power, because when I replace x here by minus infinity, it will be also 1 over infinity, which is 0. I hope you got the idea. So now the same function here, see, one time I will multiply up and down by e to the minus x. So the first one here, it will be 1, you see, because we add the power, x and minus x will be e power 0. So that will be 1 minus e to the power minus 2x divided by, this is the same, 1 plus e to the power minus 2x. So this will be 4 the expression where we have x goes to infinity. Now the second one, I will multiply the same function here, see? I will multiply up and down by e to the power x. So it becomes e to the power 2x minus 1 divided by e to the power x 2x plus 1, because you add the power here. E to the power x will become here e to the power 2x. So I will replace that in the expression where x goes to minus infinity. See, now we have the same question here. See, this is the given, this is the definition, and this is the rewriting the definition to find the limit in an easy way. Now let's evaluate the limit. X goes to infinity, see, infinity plus infinity. And we have here minus, so it will be 1 over infinity. So that's 0 here. So 1 minus 0. Also here 1 plus 0. Now here we have e to the power 2x. That's a positive in the power here. But x goes to minus infinity. So it will be 1 over infinity, which is 0 minus 1. So 0 minus 1 divided by 0 also plus 1. So 1 minus 0 over 1 plus 0, which is 1, minus 0 minus 1 over 0 plus 1, which is minus 1. 1 minus minus 1, the limit is 2. Now, for more questions on hyperbolic functions, please, you can visit lecture number 12B. And for more questions on Calculus 1 in general, you can see Calculus 1 solved questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.